Trigonometry is usually defined using the right-angled triangle definition. But there is another definition, it's called the arbitrary angle definition. And this is how it works. We can take an axis, a vertical axis and a horizontal axis. Usually we don't call them any name, x-axis or y-axis, but just for simplicity, let's call this x-axis and let's call this the y-axis. Then when x-axis is positive and y-axis is positive, we consider this to be the first quadrant in terms of degree. So 0 degree to 90 degree is the first quadrant. Now in terms of x-axis, you would notice that if we have a point x, y, then this point x would be positive and y would be positive. So in the first quadrant, both x and y is positive. From 90 degree to 180 degree, we call this the second quadrant. Here x is negative but y is positive. Then from 180 degree to 270 degree, we call this the third quadrant. Here x is negative and y is negative. From 270 degree to 360 degree, we call this the fourth quadrant. And in the fourth quadrant, x is positive, y is negative. Now if you consider sine, the definition of sine from the right angle triangle definition, we know that sine of any angle theta is opposite by hypotenuse. If we draw an angle like this, this would look like that right angle triangle, and if this is theta, then the opposite would be this length and that would be the y-axis. So this would be y-axis. Remember here y-axis is positive. Then the hypotenuse would be this, and hypotenuse would always be positive because it is not on the x or y axis. So that would be positive. Let me call this the hypotenuse, let me call this r. So sine theta would be positive. Similarly, if I put cos theta here, cos theta would be adjacent, which is x, x is positive, divided by this hypotenuse r, that would be positive. So the value of cos theta and sine theta both would be positive. If we have tan theta if you remember is sine theta by cos theta, that means both are positive, opposite by adjacent, opposite is y, adjacent x. So in the first quadrant, if we take the right angle triangle, something like that, we can say that everything here is positive. So we can say all positive. So here all is positive, sine, cos, tan, all positive. By this logic, we can say that in the second quadrant, if there was an angle here in the second quadrant, then only sine would be positive, because here sine is opposite by hypotenuse, so only sine would be positive. So we call this sine positive. In the third quadrant, similarly, only tan would be positive, so we call this tan positive. And in the fourth quadrant, only cos would be positive by that logic. So this is not an actual definition of a right angle triangle. Here this angle can have any value. For example, if you think of a right angle triangle is an acute angle. The theta that we are talking about is an acute angle less than 90 degree. But when we talk about this quadrant, if you consider this to be the angle, suppose 60 degree, and if you take this to be 60 degree, and if you take a complete revolution 360 degree and come back to 60 degree, so the angle sine 60 degree and the angle sine of 60 degree plus 360 degree would be the same value. If you take out your calculator, you will see both sine 60 and this value, which is 420 of sine, they have the same value. But if you go two more revolutions, 1, 2, and then you come here, this doesn't happen in real world. They are arbitrary angles. So if you do sine 60 plus 2 into 360, which is 720, you would say they have the same angle. Let me show you this. So sine 60 is root 3 by 2, 0.866, if we take sine 420, same value 0.866 root 3 by 2. Then if we have sine 720 plus 60 is 780, it has the same value. That means when we talk about arbitrary constants, it doesn't really refer to a triangle, because a triangle cannot have 420 degrees, 780 degrees. It refers to an arbitrary angle, and it is this arbitrary angle that we are talking about. So we can call this to be the definition of trigonometric ratio of the arbitrary angle definition. So arbitrary. Okay, if you remember, when we talk about the common angles, these are the common angles. When we have this right angle triangle definition, 45 degree, we have sine 45 degree, cos 45 degree, tan 45 degree. In degrees it is 45 degree, in radian it is pi by 4. Then we have another triangle, 30 degree 60 degree triangle. In that case we have 60 degree sine 60 degrees root 3 by 2, opposite by hypotenuse, and on, and this is the 30 degree. And then we have this value where we have 0 degree, 90 degree, 180 degree, 270 degree, 360 degree. Sine 0 degree is 0, sine 180 degree is also 0, sine 360 degree is also 0. That means in the same position they have the same value. So this is a very important chart that needs to be memorized, and or you could just remember these three pictures. So this is the definition in terms of right angle triangles definition. So remember, when we talk about arbitrary angle definition, it doesn't matter what it is, sine of any angle plus any number of revolution times 360 degree would be the same value. This goes for cos, this goes for tan. 360 degree or 2 pi in radian. So sine 60 degree, sine 420 degree, sine 780 degree refers to the same position, but since the angle is arbitrary, we can keep on going and going and going, and we can have the same position, but the angle can keep on increasing. So it is important to understand arbitrary angle definition refers to this picture, and we call this the first quadrant, the second quadrant, the third quadrant, the fourth quadrant. In the first quadrant, sine, cos, tan, all these things have positive values. In the second quadrant, only sine has a positive value denoted by this S, but cos has negative value and tan has negative value. If you think about in x-axis and y-axis, then you can see why this is happening here. In the third quadrant, similarly, only tan has positive value, sine and cos has negative value. In the fourth quadrant, only cos has positive value, sine and tan has negative value. So you can remember this by remembering this acronym CAST, CAST, or all students take chemistry, or all silver tea cups, whatever helps you to remember. Now, when we talk about solving a trigonometric equation, it is very, very important in order to do that to understand these quadrants, and in order to do that you have to understand we are not talking about a right angle triangle, we are not talking about geometry, we are talking an arbitrary angle that needs to be found from here.